OK, so how does this sort of fit together with AJAX? Sometime in like late 1998, I think, a call was added to the Microsoft Internet Explorer JS API called Xmlhttprequest, which provides a JavaScripty way to make a request out to a server that will not cause the browser to automatically redraw the page when a response comes back. The only difference between that and what we have grown used to thinking of as a regular, normal HTTP request is there is an additional header. If you looked at the request headers arriving at the server, you would see the presence of an additional header called X requested with Xmlhttprequest. So that is the signal to the server side that what the browser is expecting here is not a sort of full HTML page response view necessarily, that whoever made this call is being made from some JavaScript that's inside a browser page. And if you're writing the server, this is a tip-off on what you can do differently. Because now, what you might want to do is use this to condition your controller action so that instead of assuming that it's just going to render a view, maybe it's just going to return a piece of JSON back to the client. So assuming that we're doing a Rails server side, as we've been doing all semester, the controller action gets called in the normal way. So you have to have a route for whatever your AJAX request is, just like any other controller action. And then the question is, what should the controller action render? If it's not going to do a whole view, what should it do instead? And the answer depends on what you have designed your JavaScript code in the client to expect. The two most common possibilities are the client is expecting to receive back some data, which in practice means a JSON object. And the client is going to use that data to somehow modify the page. The other possible action is the client is expecting to receive back a new DOM element. So for example, you could have the server render a chunk of the DOM, just the same way that you render a view or render a partial. You could send that back and basically say, please insert it into the tree at this point. And in fact, it turns out that the same mechanisms are used. You can render a partial, which means what the client will get back is a chunk of HTML that is intended to be put in somewhere. And when you make the AJAX call, jQuery is actually smart enough to examine the return value and sort of figure out what's the right thing to do. Or you can say, render a JSON object. In fact, a nice property that Rails sort of has built in is that every active record model that you define, by default, knows how to create a simple serialized version of itself in JSON. So if I have assigned @movies to be some innumerable collection of movies matching some criteria, I can just say, render this as JSON. This will end up calling toJSON on every collection element. And what I'll get back is a reasonable JSON approximation of the same object. And now you can easily digest that on the client side. You can do the same thing with XML, but basically nobody does anymore. You can send just a string. Maybe it's a really simple AJAX call that's just waiting to fill in the value of a piece of text on the page. So you can just send back a bare ASCII string. Or you can send back nothing, which basically says, I'm sending a successful response header. So I'm affirming that the request was successful, but there isn't anything to display. So for an example of when you might do something like that is the user is clicking a button or checking a checkbox or something that causes the server to do something that is a state change. It causes a side effect on the server. By saying render nothing, it gives you a way to acknowledge back to the client that everything worked, even though there isn't anything specific to display in this case. Right? So these are various options. But the main message here is all of the same machinery that works to render an HTML page essentially can be repurposed to render something in response to an XHR request. How do you make the request at all? With jQuery, it is actually really, really easy because they provide a function called AJAX, which is a wrapper around a much more awkward to use set of lower level functions that are part of the JS API. Right? So ultimately, someone is going to have to call Xmlhttprequest at the JS API level, but that someone almost never has to be you. Usually, you let jQuery, or if you're using a heavier weight framework, the framework will do it for you. And the reason for this is that essentially, if you try to do it yourself, the browser will fire a whole bunch of other events to let you know that, hey, I got the request, I sent it to the server responded that it got the request, the server's working on it, the server has begun sending back data, the server has finished sending back data. And if you don't want to deal with all that, jQuery just lets you say, if everything worked, call that function. If anything didn't work, call this other function. And you can also say a timeout, which is if you don't get a reply within a certain amount of time, and you may want to handle that differently than actually getting a hard error. There's a lot of other options to AJAX, but those are the basic ones. What is the HTTP method? What is the URL or the URI part of the route? So basically, you're calling a route, and on the server side, that route is going to get matched just like any other route. Right? So most of the machinery is still in common. A typical thing that the error function might do is pop up a little alert box saying something strange happened with the server. The success function would do whatever the client-side effect of the AJAX call is supposed to be. So how does this look in a typical app? If you have JavaScript include tag applications somewhere in one of your view templates, that will trigger essentially loading all of the JavaScript code associated with your app as part of the page load. So this usually goes somewhere like the overall application layout. You've got your JavaScript code spread across potentially multiple files in the JavaScript subdirectory of your app. The machinery that essentially goes through all of those files, wraps them up, minifies them, and creates a blob that can be sent back to the client is something we have not yet talked about called the asset pipeline. And hopefully I can tell you a little bit about it on Tuesday when I talk about other JavaScript frameworks. Then you define a handler that maybe inspects element state, it looks at attributes, whatever it's going to do, and then it eventually makes an AJAX call to the server, which means that you have to have a controller action and a route that are going to receive that, just as you would for regular HTTP requests. And finally, you have a callback function that will receive whatever the server replies. So whatever the controller action is going to render as a result, your callback function should expect to digest that. If you chose to send back JSON, then your callback function is going to inspect the JSON object and do whatever it does. If you sent HTML back, if you sent like rendering a partial, then what you might use a jQuery call that says, replace the existing content of this DOM element with this new content. Right? So again, a standard trick that you see for stuff like this is, let's say that every once in a while, if something goes wrong with an AJAX call, you need to display like a little error message inline in the page. When the page is loaded, what you can often do is have an empty div. It has an ID, but there's no content in it whatsoever. So it's a placeholder. That means that on the actual rendered page, it's not visible. If an error actually occurs, what you could do is on the server render a partial that is basically a replacement version of this div. What you send back is the complete HTML content verbatim of what you want to replace, and then you use a jQuery call that says, find the div whose ID is whatever, and just replace it outright with this other one. So what you're replacing an empty element with another version of that element that now has some content. Right? So that's one of the most common uses for stuff like this is you render just enough HTML to replace part of the DOM, and it's because in your original document when the page was first loaded, you had a placeholder empty element there with an ID that is well known, and you can just replace it in place. So what does that look like on the server side? It looks exactly the same as what you've seen. The only difference here is, and what I'm showing is the show details for a single movie from Rotten Potatoes. Basically, I'm conditioning what the controller does if the request object, which is a Rails abstraction for, it's the object that encapsulates the request that was received. If XHR question mark is true, that means that that special header was present, indicating that the request is coming via an AJAX call and not via sort of a top-level page load. So if I check that that's true, then instead of doing the default behavior, which would be to render an entire view, I'm just going to render a partial. And presumably, this means that on the client side, I have some code that is expecting to receive a blob of HTML and replace it into something in the DOM. And we can look at what that code looks like. Walking through here, what happens when we haven't talked yet about what would trigger the AJAX call to be made, but setting that aside for the moment, what happens when the getMovieInfo handler is called for whatever reason? It makes an AJAX call. The URL that it's going to associate with the request, I haven't shown the HTML page that would trigger this yet, but basically this will resolve to a URL like /movies/3. So it's going to look just like the URL that you would generate for that view in a plain old Rails app. I'm specifying a 5-second timeout, which is pretty generous. If the request returns successfully, I want to call this function, showMovieInfo. And if the request throws an error or doesn't terminate successfully, I'm just going to provide a function in place. Right? Here's an example of an anonymous function. If it doesn't work, call this function right here, which is going to be passed the original XHR request object, which is not very interesting, a status description like the HTTP error code that came back, and an object representing the exception on the JavaScript side. There's various fields of those that you can inspect so you can tell the user something sensible. But in this case, I'm just going to pop up a little pop-up alert box that says an error happened. And you have to dismiss it by clicking OK or dismiss or whatever. Okay, so both the success and error functions get passed the same arguments. What actually happens if success happens? So in the controller, remember what we're doing is we're rendering a blob of HTML. And if we succeed, that blob of HTML from the server is going to be passed somehow into show movie info. In particular, the first argument that gets passed to the success or failure function is exactly what came back from the server. So in the case of success, this variable data, this parameter, is going to be a string that is a blob of HTML. Right? So my goal is to now somehow incorporate that blob of HTML into the document object model. And this particular code does it by making like a floating window that's half as wide and a quarter as tall as the screen. That window is going to be used. There's a placeholder, like an empty element placeholder, called movie info that is part of the original page load. And I'm going to take that original empty element. I'm going to modify some of its CSS properties, in this case to position it. I'm going to change the HTML content of the element to be the thing I just got from the server. Right, so here's an example of using that trick where movie info was present in the original page, but it was an empty element. It was a div that had no content in it. And now I'm replacing the inner HTML of the div with whatever the server gave me back. And finally, I'm going to show it. Because if I showed you the original page where it was loaded, the original page had it as a hidden type element. So that even if there was some text, like even the space that it takes up wouldn't be visible on the page. Again, I'm using this chaining thing, right? Once I've gotten the element or collection of elements that matches it, every call that I make on it also returns its receiver. So I can chain all of these together, and it's like they're all operating on that same collection. And so if you want to sort of read about like line by line, play by play, how the entire example works, we won't have time to sort of walk through the whole thing here. The rest of it is spelled out quite in detail in the book. But basically what it's doing is it modifies the Rotten Potatoes app so that when you click on a movie name, instead of going to a new page showing just that movie's details, it shows a pop-up that has the movie details. And then if you click the close box of the pop-up goes away, and you're still back on the main movie listing screen. That's why the last thing that this show movie info does is it actually generates it binds a handler so that if you click the close button in the pop-up link thing, it will actually call hide movie info, which just hides the div again. So it's a pretty simple example, all things considered. The thing that I take away from this example is the number of different places your brain has to be when you're writing this kind of code. So your brain has to be in this place, which is at some point the user is going to do something that triggers a request to the server to get data to put into this pop-up window. So that's one piece of code you have to think about. But you've also said, depending on whether the code succeeds or fails, there's two other places my brain has to be. Right? Think about what would this code look like if JavaScript did not have the constraint of being exclusively non-blocking. Right? Imagine what this code would look like. It would probably say something like, if something equals request to server, if the request succeeds, do some things, else do some other things. But that's the part that, when you're writing JavaScript, you have to tear all those pieces apart. Why? Because the moment you say something like, if the request is successful, well, if that is a long-running thing, meaning anything other than basically instantaneous, you cannot wait for it to finish. So you have to sort of split up your code into, I'm going to do stuff up until the moment that I hit a long-running request. At that moment, I have to essentially throw the request out into the universe and specify like the if-then conditions for what happens when it returns, which could be sometime in the future. Or if it doesn't return at all, right? The third case is that it times out. The server doesn't reply within 5 seconds. That's a third thing. So even for this relatively simple behavior, there are 2 or 3 different JavaScript functions that are all implicated in making the behavior happen. And this is the thing that, to me, makes it challenging to think about this kind of code. Thinking about asynchronous code involves taking to me, what's a very simple structure of like, if something succeeds, do this, else do that, and tearing that apart into all the pieces. There's an if piece, there's a then piece, and there's an else piece, and now they're in 3 different functions. So keeping your JavaScript code organized and keeping your brain wrapped around that, to me, is sort of the challenge of writing JavaScript in any capacity.